Um, Here we are going to introduce the application of MIMO technology in LET system. So, in this presentation, the utilization of multi-antenna techniques in LTE is introduced. The principle of multi-antenna techniques is introduced first. Then a brief introduction to the LET system is present. Finally, the application of multi-antenna techniques in LET system is provided with several practical constraints taken into account.
Over this.
So first, we will talk about the MIMO techniques. Multiple antennas can be used as a transmitter and receiver. An arrangement called a multiple input, multiple output system. A MIMO system takes advantage of the spatial diversity that is obtained by spatially separated antennas in a dense multi-pulse scattering environment. MIMO system can be implemented in a number of different ways to obtain either a diversity gain to combat signal fading or to obtain a capacity gain. Generally, there are three categories of MIMO techniques. The first aims to improve the power efficiency by maximizing the spatial diversity. Such techniques include delay diversity, space-time block codes, we also call it STBC, and space-time trellis codes. The second class uses a layered approach to increase capacity. One popular example of such a system is V-Blast, where full spatial diversity is usually not achieved. Finally, the third type employs knowledge of channels as the transmitter. It decomposes the channel coefficient matrix using singular value decomposition and uses this decomposed unitary matrices as pre and post filter as the transmitter and receiver to achieve near capacity. So this is a MIMO signal, and now we will talk about the spatial diversity for the MIMO signal. The spatial diversity-oriented design will feature some level of repetition between the entries. For full diversity, each transmitter symbol must be assigned to each of the transmitter antennas at least once in the course of the symbol duration. The result symbol-to-transmit signal mapping function is called space-time block code. Although many designs of space-time block codes exist, additional properties such as authority of matrix Y allow improved performance and easy decoding at the receiver. Such properties are realized by the so-called Alamuti space-time code. And then we will talk about the spatial multiplexing at the figure on the right. So a simple method to achieve the spatial multiplexing is Bell Labs, which is called, so we call the name of that is BLAST, which is a parallel encoding here. And we will skip the basic the details of how it realized and jump to the MIMO channel decomposition directly. The optimal way for communicating over MIMO channels involves a channel-dependent procoder, which fulfills the role of both transmit beamforming and power allocation across the transmitter stream, and a matching receive beamforming structure. For channel knowledge is therefore required at the transmit side for this measure to applicable. Then we will give a brief introduction of the LET system. Mobile broadcasting has become a reality as the internet generation grows accustomed to having broad access wherever they go, and not just at home or in the office. Out of the estimated 1.8 billion people who will have broadband by 2012, some two-thirds will be mobile broadband customers, and the majority of these will be served by HSPA, high-speed packet access, and LET networks. People can already browse the internet or send emails using the high-speed packet access enabled notebooks, replace their fixed DSL modems with HSPA modems or USB, and send or receive video with video or music using 3G phones. With LET, the user's experience will be even better. It will further enhance more demanding applications like interactive TV, mobile video blogging, advanced games, and professional search. LET offers several important benefits for customers and operators. The first one is the performance and capacity. One of the requirements on LET system is to provide downlink peak rates of at least 100 megabits per second. The technology allows for a speed over 200 megabits per second. Furthermore, the radio access network round trip times shall be less than 10 milliseconds. In effect, this means that the LETC, more than any other technology C, will meet key 4G requirements. So the second benefit is the simplicity. So first, LED supports flexibly carrier bandwidth, and there are more band to come. So this means that an operator may introduce LET in new bands where it is easiest to deploy 10 megahertz to 20 megahertz carriers, and eventually deploy LET in all bands. The second means that the LET radio network products will have a number of features that simplify the building and management of next-generation network. For example, features like plug and play, self-configuration, and self-optimization will simplify and reduce the cost of network rollout and management. Third, the LET will be deployed in parallel with simplified IP-based core and transport networks that are easy to build, maintain, and introduce services on. And the third benefit is wide range of terminals. In addition to mobile phones, many computer and customer electronic devices such as notebooks, ultra-portables, game devices, and cameras will incorporate LET embedding modules. Since LET support handover and roaming to existing mobile network, all these devices can have ubiquitous mobile broadband coverage. The fulfillment of the extensive range of requirements is only possible thanks to the advance in the underlying mobile radio technology. There are three fundamental technologies that have shaped the LET radio interface design: multi-carrier technologies, multi-antenna technologies, and the application of packet switching to radio interface. Since the aim of this article is about how the application of MIMO, so we will focus on the MIMO in LET in next step. So at first, we'll talk about the gap between dream and reality. A few important practical constraints are briefly reviewed which affect the real-life performance of the theoretical MIMO system considered above, and which often are decisive when selecting a particular transmission strategy in a given proportion and system setting. Another source of discrepancy between theoretical MIMO gains and practical achieved performance lies in the ability of receiver and, whenever needed, the transmitter to estimate the channel coefficient perfectly. The second aspect we are talking about is the transmit diversity. The theoretical aspect of transmit diversity were discussed in the last series. Now we will discuss the two main transmit diversity technology in LET system. The first one is the space frequency block code. We also call it SFBC. If a physical channel in LET is configured for transmit diversity and operating using two E-node B antennas per SFBC is used, SFBC is a frequency domain version of the well-known space-time block codes, also known as elemented codes. This family of codes is designed so that the transmitted diversity streams are orthogonal and achieve the optimal SNR, the signal noise reduced with a linear transceiver. Such orthogonal codes only exist for the to transmit antennas. The second is called frequency switched transmit diversity, and its combination with SFBC. General FSTD schemes transmit symbols from one antenna on a different set of carriers. In practice, in LVT, FSTB is only used in combination with SFBC for the case of 4 transmit antennas in order to provide a suitable transmit diversity scheme where no orthogonal reach one block codes exist. And the third aspect we're talking about is spatial multiplexing schemes. There are 2 ways to realize spatial multiplexing in LET: closed and open loop spatial multiplexing. So the closed loop spatial multiplexing is also called precoding with codebook, and the open loop spatial multiplexing is also called cyclic delay diversity, as shown in the figure before down. So I think that's all I want to talk about today. So in this slide, the principle of multiple antenna techniques and their application in LET system was introduced, and a considerable of difference between theoretical results and practical constraints were also present. These discussions revealed the necessity for students majored in engineering to acquire some experience or understanding on practical systems. Meanwhile, with LET system deployed, it is urgent for students majored in telecommunication to acquire a fundamental understanding of LTE. I think that's it.